Hey guys, so this is unit circular functions. Today we're going to be talking about using a trig identities to solve problems. So these are the four identities that you really need to be familiar with, and I say four. These identities are the same thing, it's just that you can use these other three to get to them. And this is how they're displayed in your book. These are the four that you're given. So make sure that you're familiar with them. You don't need to memorize them, but make sure that you're familiar with them. The first example, given that sine of x equals 3/4 and that x is in between 0 and 90 degrees, find the exact values of cosine of x, sine of 2 of x, and cosine of 2 times x, and tangent of 2 times x. So keep in mind that x itself is in between 0 and 90, but 2x could be outside of that. Okay, so if we get a negative cosine, that's fine, or a negative cosine of 2x, that's fine because it's 2 of the x. Okay, I know that seems silly, but yeah. Anyway, so if we wanted to find cosine of x, we're only given sine of x equals 3/4. There's two ways that you could do this. You could make the triangle and find out the adjacent, or you can say, all right, I know that I have this identity, cosine squared of x plus sine squared of x equals 1. I could use that to solve my unknown, which is cosine of x. So let's do that, just to get in the habit of solving for an equation. So I know that the problem is the identity is cosine squared of x plus sine squared of x equals 1. That's the identity. Now I have sine of x, so I could do it as cosine of x squared plus sine of x, which is 3/4 squared, equals 1. And then I just solve for cosine of x, because that's the unknown that I want to find out. So I can subtract 9/16 from both sides. And I drop down the cosine of x squared. And that's going to equal 7/16. And then I just take the square root of both sides to get rid of that square above the cosine of x. So you get cosine of x equals the square root of 7/4. And this is your answer. And let's do B, which is sine of 2x. Again, I'm asking for sine of 2x, but I'm only given sine of x. Now I know my cosine of x, which is square root of 7/4, so I can use this trig function in order to find sine of 2x. So I have sine, oops, that is ugly, sine of 2x equals 2 sine theta times cosine theta. And because I know both of these values, I just substitute them. So I have 2, and then sine is 3/4. Cosine is square root of 7/4. And so when you evaluate this, you should get 3 square root of 7/8. Pretty simple. You just have to know which trig identity to use. So we have sine of 2x. Now let's do cosine of 2x. So cosine of 2x, I have 3 different options, right? Now I have cosine and I have sine. I think that that is going to be the best one to use, which is the first one. So cosine of 2x equals cosine squared of x minus sine squared of x. And just like I did before, I'm going to substitute in cosine, which is square root of 7 divided by 4 squared, minus the sine of x, which is 3/4 squared. And when I evaluate this, you'll get -1/8. Here, I'll show you what it looks like. So when you distribute that square, you get 7 over 16 minus 9 over 16. You subtract, you get -1/8, or -2 over 16, which is -1/8. So that's cosine of 2x. Now tangent of 2x. As you can see, there is no double angle of tangent, right? But I know that tangent of x equals sine of x over cosine of x, and that would be the same if it was 2x. So tangent of 2x equals sine of 2x over cosine of 2x. And I already know what those values are, so I can just substitute those in. So you have 3 square root of 7 over 8, all over, because that's sine, or sine of 2 theta, or 2x. And then cosine of 2 theta is -1/8. So in order to get the get rid of the fraction within a fraction, I multiply by the reciprocal. And the bottom cancels out, or equals 1. And then the top is going to be -3 square root of 7. Okay, I think we should do another one. Okay, so given that tangent of theta equals 3, and theta is between 0 and pi, find the value of sine of theta and cosine of theta. So even though our theta is in between 0 and pi, tangent being positive means that theta is only in the first quadrant. Okay, so I'm going to draw it like as it was in the first quadrant, right? My theta would be over here. So one thing I know about tangent is that it's opposite over adjacent. Whenever you have a whole number, there's always a 1 underneath it. 3 divided by 1 is 3, right? So the opposite is 3, the adjacent is 1. If you do the Pythagorean theorem, you're going to get square root of 10 as your hypotenuse. Now that I know that, I can quickly say that what sine of theta equals and what cosine of theta equals. So sine of theta is going to be the opposite, which is 3, over the square root of 10. But we cannot have radicals on the bottom, so we move them to the top by multiplying both the denominator and the numerator by square root of 10. So we get 3 square root of 10 divided by 10. Now for cosine. Cosine is adjacent over hypotenuse, so I get 1 over square root of 10, which equals the square root of 10 divided by 10. Okay, so now you know how to do that we know from before, right? Now we're going to use our identities to find sine 2 theta and cosine 2 theta. So sine 2 theta. Again, we're just going to use the one that it equals. So 2 sine theta cosine theta. And we know that sine of theta is 3 square root of 10 divided by 10. And we know that cosine of theta is square root of 10 over 10. When you work this all out, you'll get like 2 times 3 times 10 over 10 times 10. And then like this cancels out with this, and then you can make this a 5, so you get 3/5. That is sine 2 theta. Now, cosine 2 theta. I'm given the sine and I'm given the cosine, so I'm just going to do that one. Or I guess you could do any of them. You have all of the information for them. But I'm just going to go with it. So cosine of 2 theta equals cosine squared of theta minus sine squared of theta. We know that cosine of theta is square root of 10 over 10, and that's squared, minus the sine of theta, which is 3 square roots of 10 over 10 squared. And I'm pretty sure that you guys can evaluate this on your own, so I won't waste time. We get -1/5. Okay, so pretty simple stuff. I think we'll get more practice on it tomorrow. Have a good evening.